This is 6.6a of geometry. So we've got a trapezoid here. I would just draw this out and label it trapezoid if I were you. So I've got two bases, one on the top, one on the bottom, and those are parallel. And then we call the side things legs. And all of these angles are considered base angles since they're touching a base. We've got a specific kind of trapezoid. It's called an isosceles trapezoid, this one, where the two legs are congruent. And if you think back, we've talked about isosceles triangles before, and that was a triangle that had two sides congruent. So it should be pretty similar. It shouldn't be a surprise. Okay, so we've got a theorem here that says if you have an isosceles trapezoid, then these angles are congruent and these angles are congruent. Right? So as long as it's an isosceles trapezoid, then I know these two are congruent and these two are congruent. Okay, so let's look at this trapezoid here. So, using that theorem, I know that this angle is congruent to this angle, and this angle is congruent to this angle. So, just by looking at that already, if R is 106, then that means S is 106. But now I need to figure out what Q and P are. So, think back quite a while. If these are parallel lines, what kind of angles are these ones right here? They're same side interior angles. And what do we know about same side interior angles? They add up to 180. So if I call this one X, X plus 106 needs to equal 180. So I can subtract 106 from both sides. So I get that X equals 74. So if this is 74, since these are congruent, I know that this one is also 74. There we go. So, we're going to look, for a second, let me jump back to this theorem. If I look at this trapezoid here, if I extend this, and so that these are congruent, this is now an isosceles triangle, okay? If this is 3, that's 3. If this is 5, this is 5. So this whole side would be 8, and this whole side would be 8, right? That's an isosceles triangle because two sides are congruent. We had a theorem that said if legs are congruent, then base angles are congruent, right? That's part of where they're coming out of. So I can take all of that and apply that here, okay? So we're told that this angle in there is 15 degrees, okay? So if I'm just going to draw it separately. So this is an isosceles triangle and an isosceles trapezoid. So if this down here is an isosceles trapezoid, then I know that this is also X, right? The bottom two are congruent. And this one is also Y. The top two are congruent. But that doesn't involve the 15 at all. Somehow I need to get that 15 involved. Well, if we look at this as a triangle, I know that my three angles need to add up to 180. So 15 plus X needs to equal 180. So I get 15 plus 2X equals 180. If I subtract 15, I get that 2X equals 165. And then if I divide by 2, I get that X is equal to 82.5. So these two X's down there are 82.5. So 82.5, 82.5. Okay. Now, remember, these are same side interior angles. They need to add up to 180. So, Y plus 82.5 equals 180. I'll subtract 82.5. So I get that Y equals 97.5. So those two Y's are 97.5. Okay, here's another theorem. says if it's an isosceles trapezoid, then the diagonals are congruent. So if it's an isosceles trapezoid, then the diagonals are congruent. And here's another theorem. This one's a bit of a doozy, so stick with me. Okay, so this line right there, the one that goes across there, that is our midsegment. So, if it's a trapezoid and we have our midsegment marked, then we know that these three lines are congruent, or sorry, not congruent, they're parallel. Those three sides are parallel, so I can mark that. And I know that if I add this top one and the bottom one, so if I'm given their lengths and I add those, and then I take half of that, or I divide it by 2, that will give me how long my midsegment is. So the top plus the bottom, and then divide that by 2, that'll give me how long my midsegment is. So let's try one of those. We're going to work on this problem, but let me try a little bit of an easier one first. Okay, I'm going to draw my own. If this is 3, oops, let me mark that it's a midsegment, and the bottom is 7, let's say. So I add the top and the bottom, 3 plus 7, which gives me 10. Then I take half of 10, that's 5. That's how long my midsegment is. So my midsegment would be 5. Right? We add the top and the bottom, divide that by 2, and that gives us how long our midsegment is. So we're going to try it with an expression in this one. So I'm going to add the top and the bottom. So 10 plus 8x minus 12. So the 8x is going to stay alone. 10 minus 12, or 10 plus a negative 12, that'll give me negative 2. So then I need to take half of that. So 4x is half of 8, right? And half of negative 2 is negative 1. So I get 4x minus 1. So that's how long my midsegment is. So I can set this equal to 2x plus 11. And then I can solve for x. So I'll subtract 2x, and I get that 2x minus 1 is equal to 11. Add 1, and I get that 2x is equal to 12. If I divide that by 2, I get that x is equal to 6. If you want to use the equation that was in that theorem that we just did, you can do that. It's just going to be doing it all at once. So you'd add 10 plus 8x minus 12. You're going to take half of that, and that'll be equal to 2x plus 11. If you solve that one, you do the same steps that we just did. It's just all together now. And you're still going to get the same answer. There's your homework.